Okay, so we just discovered that you can borrow up to about $10,345.11 to buy a car. Right? That's the kind of car you can afford if you can only afford to pay $200 a month for the next 5 years at 6% compounded monthly. All right, I want you to notice something here. Now, notice here, you're paying $200 a month, 12 times a year for 5 years. So if you multiply these simply together, you get $12,000. Now that is what is called your total payment, sometimes total payments in plural. And so that is how much you're paying for the next 5 years, even though you're only borrowing a little more than $10,000, right? So what's the difference? Where is the difference going? I mean, you're paying a lot more for your car than how much you're borrowing, right? So this is your total payment. And I want you to find the difference. Okay, so let's subtract $10,345.11. And if you find the difference, and I'm not going to show you this on your calculator because it's a simple subtraction problem, you will get $1,654.89. This difference between the total payment and the amount borrowed or financed is precisely the total interest paid. Okay, you see the difference here? And do you see why this is the interest that you're paying? Yeah, I mean, this is pretty simple, right? This is how much you pay. This is how much you borrowed. And the difference is precisely what is called the finance charge or financial charge, otherwise known as the amount of interest you paid for the next 5 years. Okay, and so this is exactly how you find how much interest you are paying whenever you borrow money to buy a car or a house, or when you are using your credit card and not paying off your credit card every month. Okay, so the difference between the total payment and the amount borrowed is called the total interest paid. I hope this is clear. And this is how you find the total interest paid in every kind of loan or mortgage. All right, now I want to go to the second page here, and I want to call your attention to something even more practical than what we just did. Okay, because typically what happens is people are not going to simply calculate, okay, what kind of car can I afford? How much money can I borrow if I can only pay $200? You know what's more realistic? Yeah, you walk around the lot and you say, oh, I want that car. Or you walk around the street, or your real estate agent will take you to places and say, oh, I want that house. So typically, this is what's given. And based on that, you want to determine how much you have to pay to afford that house or the car, right? So the more useful question is, how much do I have to pay every month? Because I really want that car or I really want a house. And so a more useful formula is not the one asking for the P, the present value or the amount you can borrow, but instead this D, the monthly payment amount. That's what you really want to know. Okay, so we had this formula, which was P is equal to D times, remember? And it goes like this. It's 1 minus 1 plus R over K. You don't have to rewrite this because you just wrote this on page 1, all divided by R divided by K, right? So this big chunk is a fraction. Now, if you are given this, and if you want to find this, what do you have to do? Okay, let's just call this a big block, a blob maybe. Yeah, B-L-O-B, blob, right? So in order to calculate D, all you have to do is divide both sides of this equation by this blob, because that's going to isolate D on one side. So D is actually P divided by this big blob. Okay, let's just call this big blob. Yeah, there. Okay. Now, when you divide by a fraction, because this big blob is itself a fraction, I'm talking algebra here. If you want to ignore me for like a minute, that's okay. If you are dividing by a fraction, do you remember your elementary school lesson on division by a fraction? Invert and multiply, maybe, if you remember. You basically switch the top and the bottom and change that into multiplication. So this will become P times what we used to be on top, okay? And then the denominator, which is blah, 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 to the negative exponent, right? And that is going to be a more useful formula. So let me show you this more useful formula here. This is to find the amount of your monthly payment. D is equal to P, the amount of loan, times, you ready for it? R divided by K. Remember, this is the rate per period. And then the new denominator is what used to be on the top of that formula. It's 1 minus parentheses 1 plus R over K. Remember, R over K is the rate per period. And then the exponent will be negative KT, KT being the total number of payments. Often it's 360 because a typical house mortgage is for 30 years. Every month, that's 360 payments you have to pay in order for the house to become completely yours. So that big formula is what we call a more useful formula. D is the amount of each payment, usually the amount of monthly payment. And then P is the amount you are borrowing, amount of the loan. All right, and we're about to use this to calculate something very specific here in this example, but I hope this makes sense. Now, again, this is a big formula. Most people do not use this in their real life. Even the real estate agents and the people involved in real estate transactions just use formulas. Probably I'm the only one who actually used this to calculate the amount of each payment when I go to a car dealership to buy a car or something. And, you know, because this is complicated and you do not have to memorize it. You do not have to, well, you do have to use it for homework. Okay, of course you can look at this, but you do not have to memorize this because I will not ask you any questions that would require this formula on your exam. Right now, remember your exam is not open notes or open books, so you will not be having access to notes. All right, let's use this example to illustrate this formula. Suppose you are, and this is very practical. Let's say you are buying a typical and modest home in Santa Clarita, priced at $647,200, which is sort of like the median price of a house in Valencia. Suppose that you pay, actually, maybe it's more, more now. Suppose you can pay $47,200 as your down payment. Now, remember, notice here, this is a pretty sizable down payment, right? You have been saving money, and this is close to 50,000 you have saved up. Now you think you're ready to buy a house. And so you use this as your down payment, and that's going to give you the financing amount of $600,000. You will have to take a mortgage on the rest of this. And by the way, this is only the difference between this and this. And that's the money that you need to have financed on your home mortgage. So you can take out a loan for $600,000. The term is 30 years and the interest rate is 3.6% to be paid every month. Let's calculate the monthly payment. All right. Can you identify the variables? What's R? Okay. R is 3.6%, which you write as 0.036. Okay. What else? K. Of course, it's 12. K is almost always 12 because you are making payments monthly. And then the next thing you need to know is, let's see, T. What is the term? That's 30 years. T is always in terms of in years. And then P is, of course, $600,000. Right? With all the ingredients, now we can put them in this pot called the formula, and we can cook it to come up with the answer. So the D, the amount of your monthly payment, is going to be 600,000 times R over K. And by the way, R over K is something that appears twice, you know, here and here. So you might as well want to calculate this. It's this divided by that. And if you do that, it's 0.003. In other words, it's a 0.3% every month. That's exactly what we mean by 3.6% calculated monthly, compounded monthly. All right, so on the top is 0.003. And in the denominator, which is used to be a numerator, 1 minus, okay, and then 1 plus R over K. 1 plus 0.003 is 1.003. and then you raise it to the power of negative KT. Now, the negative KT is the total number of payments, which is 360, as we have seen before. Whenever you take a 30-year mortgage and you have to pay monthly, that turns out to be 360 payments. Okay, after which, and only after which, the house will become completely yours. Okay, all right. So this is how much. This is how you calculate this. And let's go ahead and let me share this time the calculator, and then I will show you how to get there. This will answer that big question: how much do I have to pay every month for this house, excluding property taxes and other things? All right, let's see how we do this. Okay, so here is maybe a slightly different calculator. You can use your own calculator. Sometimes the plus minus sign and the exponential sign is different. So just be sure to know how your calculator works. All right, so what we have is, let's do the denominator. Let's see. No, let's go ahead and do that big fraction. Okay, so it's 0.003. You see 0.003. Now divided by, and scientific calculators do come with these exponents. So let's use the, not the exponents, the parentheses. Okay, and by the way, on the top corner, you see 0.003 divided by, parentheses open, and then I'm going to do 1 minus 1.003 raised to, that's this, negative 360. So for this calculator, I don't put negative 360. I put 360 negative, okay? And so I can see what is happening here because of the display on the right-hand side. I have to close the parentheses at this point, okay? And that is, let's see what I got. It's a strange decimal number, right? 0.003 divided by, parentheses, 1 minus 1.003 raised to the negative 360th power. Graphing calculator, scientific calculator, all these calculators know that the exponentiation takes precedence before or over the subtraction. So the order of operations is followed. And so this is exactly what we have in the big parentheses. All right, now I'm ready to multiply this by $600,000, and that's exactly what we have. And I'm about ready to press the equal sign. Remember what we're looking for. We're trying to find out how much you have to pay every month in order to buy an average, median Santa Clarita home. After you pay a sizable down payment and you are borrowing $600,000. So $600,000 over the 30-year mortgage at 3.6% comes down to this amount that you have to pay every month, $2,727.87. Okay, let's go back to our notes and write this number down. And just reflect on this. Okay, can you afford this? What kind of job do you have to have? And this is, of course, just a house. Okay, let's go back. All right, so the amount was 2727.87. Okay, so this is how much you have to pay every month for the next 360 months. And remember, in addition to this, if you become a homeowner, you end up paying the property tax on your home, not to mention sometimes homeowners association fees, other maintenance costs, and so on. So home ownership is not cheap, right? Especially in a suburb like Valencia or Santa Clarita. And so this is how you calculate this. Now, remember, this is a useful formula, right? Because it's going to tell you exactly how much you have to pay every month to buy your dream house or dream car. All right, now I think you can answer the next 3 questions as you go to the next segment of this video. Try to figure out, now this is how much you have to pay. So you multiply this by 360, and that will give you the total payments for the next 30 years. And if you subtract this amount, you do this minus 600,000, that's how much you're overpaying, which is your total interest paid. right? And then see if you can, we can do part 4 as well. So let's stop here and try to go ahead and use your calculators to calculate these next 2 questions. And when you think you have the answers, watch the next part of this lesson.